In case you hadn't noticed already, I'm very nitpicky, at least when we're talking about it, the details of how you go through and solve these problems. And that is not because I don't believe that you can solve these problems. I do believe that you can solve these problems in your head. When we change the units, you're not going to be able to. Right? So when you solve a problem, there's two things you can look at: doing it in your head and doing it on paper. If you trust doing it in your head, then you're fine. You get it right. Right? But if it gets to the point where you can't do it in your head and you can't trust what you do on paper, you've shot yourself in the foot. You're going to have to relearn the entire process. Right? So work with me here. Struggle through this part. Learn the process. So when we move further on, you're not trying to learn the process and something new. Okay? Do we need to work through these two examples again? I heard a yes. We are working through these? Yes? No?
The second one.
Yes. Second one. Okay, let's work through the second one. Yeah, we did kind of whip through that. So let's erase that top thing. And I'm going to do the solve up above, and then I'll show my kind of sort of shortcuts with mathematics down below to get us to an answer. So with all conversion problems, your very first step,
Write your units.
write your units, and in particular, write the units of what? What you want. What are you trying to get to? And you'll notice that I'm putting the equals there with no space to write a number, because all I'm now going to do is then write the unit of micrograms, and now I have no space to write a number. I don't care. Right? That's what multiple lines are for. What this is setting up the work for it, right? Getting you through that process. We don't need space to write the number. Once we know what our calculation is supposed to be, then we can worry about the number. That's what our calculator is for. Okay? Next step. What is it, the next step? Maybe I should phrase it as a question. What do you have? Okay, well, what did we start with? Okay. I agree, you all said the number first, but I want the unit first. Make sure I'm lining this up roughly. We've got milligrams. You'll notice I didn't leave a whole lot of space again, because again, I don't care about the number per se. I can put those numbers in later. Step 2 is dealing with our conversion. And only because I know the answer, I'll make that line a little bit longer. Okay? So, ideally, what do I want to happen? What we do is look at the beginning and the end. Milligram, microgram, are those the same unit? No. So what has to happen in the milligram? It must be changed. I have to get rid of that unit. How do I cancel that unit? I need the milligram unit on the bottom, okay, so that it can cancel with the other milligram unit. What answer do I want? So what ideally would I be able to put in the numerator? Microgram. Okay. Is there a... And everybody says yes to this, so we're trying to phrase this in such a way that you can't say yes. Is there a direct conversion that you know to do this? No. Okay? So if you don't know, that's fine. Okay? But that means we have to change our conversion. So now the question becomes is what can I convert milligrams to? Okay? At this stage in the game, we're relatively narrow on the amount of units we've got, so at this point we can really only go to grams. I'll even change the color on this. Okay. Is that where I want to go to? I don't know. Maybe it is, maybe it's not. Okay. But I'm going to test it and see where I can go from there. Okay. I would also make the argument that I don't need the numbers quite yet. Okay. The main reason why I would say I don't need the numbers is the first thing I would ask, do I know the conversion between grams and milligrams? Yes. If I know it, I'm fine. Let's assume it works. We'll move to the next step. Is grams the final answer for my unit? No. No. So what needs to happen? It needs to cancel, which means gram in the next conversion factor needs to show up where? On the bottom. What do I want to convert grams to? What do I want for my final answer? Micrograms. And this is where we kind of run into a gray area here. Is that a conversion factor that is provided for us explicitly somewhere? It is explicitly mentioned in the textbook. If this was on the exam, at the very front of the exam, you would probably see, actually, you'd probably see this. Micro equals 10 to the negative 6. Yes? Questions back? You guys are good. Just checking. Okay. So what does that mean? Do I have a conversion between grams and micrograms? Yes. Okay. That conversion is now on the front of the exam. We have that information. The micro means 10 to the negative 6, which means when I now track my units, what unit would I end up with? Milligram cancels with milligram, gram cancels with gram, and I'd have units of micrograms. I've set up my units properly. Now I've got to make sure I can do the math properly. So that means now going back to each of those conversions and saying, what numbers do I put in there? Okay. This is not arbitrarily picking random numbers. It's the numbers that tie milligram to gram. Okay. So now the rest of the question is completely irrelevant. What is the relationship between grams and milligrams? What does milli mean? 10 to the negative 3. Okay, you are required to know that. So 10 to the negative 3 is what the milli means. So where does the 10 to the negative 3 go? Where does our power of 10 go in our conversion factor? Our power of 10 always goes with our base unit. Okay? There was some confusion that popped up in the tutoring center about this. What is the base unit? Gram. By base, I'm not saying bottom. I'm saying the base unit. So for mass, it's grams. For distance, it's meters. For volume, it's liters. For time, it's questionable, but seconds. Okay? So our power of 10, milli, 10 to the minus 3, needs to show up in front of grams, in front of our base unit. What shows up in front of milli? 1. Move to the next part, or questions on that part. Okay. The next one. What did micro mean? 10 to the negative 6. There's my power of 10. Where does the power of 10 always need to show up in front of?
The base unit.
The base unit, which happens to be grams. So where does that show up? In front of the grams. Nice touch. 10 to the minus 6. 1 microgram. I now have the system set up where I could potentially go through and solve. There's a variety of ways to go through and do this. At this point, we've already got the unit set up. We're now just dealing with the calculator. This is a relatively short one, so it's not that big of a deal, but let's go ahead and write it out. What I would do is do 325 times 10 to the minus 6. That's not minus 6. Let me do that math again. 10 to the minus 3 times 1. Okay. I would then write out the division of 1 times 1 times 10 to the minus 6. My calculator would spit out an answer, 0.325, and it would tell me 1 times 1 times 10 to the minus 6 is 10 to the minus 6. We could then punch it into the calculator, 0.325 divided by 10 to the minus 6, and it will give me an answer. Okay? That's the calculator approach to it. Okay? For longer problems, that is exactly how I solve it. Can you cut out steps? Any number times 1 is that number, right? So you don't have to do all the multiplications of times 1 all the way through, because it's not going to change anything. Okay, so you could potentially cut steps. That will then spit out in your calculator, if I do this math right, theoretically, right?
Yes.
Okay. And we'd be wrong.
Micrograms.
Micrograms. That's what the calculator will do for you. Okay. Let's switch this up now, or any questions about what I've got written down there, because I'm about to erase it all. Okay, let's erase the bottom. How would I go through and approach this? Very, very similarly. Well, what I would do is say I've got 325 times 10 to the minus 3 over 10 to the minus 6. You'll notice that's almost identical to what I had before, right?
Yeah, you just left the ones
Okay.
out. because-
I just left the ones out. Okay. Next part. How many of you love fractions? I agree with you. I don't like fractions either. So I want to get it out of a fraction, which means I need to get rid of the denominator. So what I'm going to do is look at the calculation in the denominator and say what's going on with that. It is 10 to the minus 6. What did the minus mean?
Inverse?
Inverse, meaning I need to do that calculation, 10 to the 6th, in the other location. What's the other location of the denominator? Okay. Why do I not mess with the 10 to the minus 3? It's in the numerator. If I swap that, I drop it into the denominator. It's not wrong. I can do that, but then I'm right back at a fraction. So I'm not touching that one in the numerator because that keeps it out of the fraction system. What does that then equal? Well, 325 times 10 to the minus 3 plus 6. Okay? Which, yes, is what you said, but try to keep minimal operations. Which then means I get an answer of 325 times 10 to the third. That 10 to the third, is that a bigger number or a smaller number? Bigger number, which means when I go through to shift the decimal to my final answer, where should I be shifting it? This direction or that direction? Which way gets me a bigger number?
To the right.
To the right, which means now I have my answer. Notice no calculator. Does it always work that way? No, sometimes you'll do other things. But when you just have powers of 10, you can usually shortcut some of those steps. Are you comfortable with shortcutting those steps and doing the powers of 10? I don't know, it's your call. If you're comfortable with it, do it. If you're not comfortable with it, this is why you have a calculator. Yes?
Do we have to convert it to the base unit before we convert it for anything?
So, good question. Those of you that are super comfortable with the prefixes on sliding values, there's that King Henry loves ducks that are purple pintos. I don't know. There's that weird, stupid phrase that tells you different decimal places, and I have no idea what it is. Okay, so you can already start to pick up an opinion of what I think of that process. Okay, it's completely meaningless, useless facts. Okay, follow the powers of 10. You don't have to worry about it. That method applies to everything. Following King Henry's ducks through the swamp doesn't apply to everything. All that will apply to is when you're dealing with powers of 10. So in this section, does it work? Yes. When I move to a different section and you're now used to King Henry, you've shot yourself in the foot. You can't process forwards. Make sense? Okay. So there are shortcuts. Those shortcuts tend to work only in particular systems. That's why they're shortcuts. They shortcut one step. As soon as you move to a different problem, you don't have that shortcut anymore. If you're used to using the shortcut, you don't know how to get through it the long way. Okay? Yes?
I don't understand when you would do this inverse versus doing the before. Like what we did before, and we got that same answer. Why would you do this?
So I showed you two ways to go through and get to the final answer. And both ways we got to the exact same answer. In the first method, it was purely using the calculator all the way through. Okay? Perfectly valid, and I would kind of expect most of you to be doing that. This method is slightly more advanced. So those of you with more mathematical brain knowledge or 30 years of experience doing it can go through and do this method. So there's two ways. Your units problem all comes out the same. So the chemistry is dealing with the units. The math part of it is dealing with the numbers. And there's two approaches to that. You can go through the mathematic shortcuts, or you can go through and just punch it into the calculator and trust the calculator is going to work for you. Right? Either method works. Does that make sense? So if you don't understand this, don't use it. Okay? Other questions? Yes?
So do we need to change that, basically convert that powers of 10 to the final answer always? Or?
No. So there'd be plenty of ways that you could go through and write out this answer. Let me clean up some, whoops, not clean it up that way. Possible ways to write this answer. 325 times 10 to the third. All of these are micrograms, so I don't want to keep writing that. 325,000, 3.25 times 10 to the sixth. Yeah. 6. No, it'll be 5. You're right. Give me another one. Is there another one? I think that's it for the ways that you could possibly represent it. Okay. On a multiple choice test, would you see all 3 of those?
No.
God, I hope not. That would be kind of mean. Okay. If you did see all 3, that becomes problematic. Okay, so let's work through based on what we've looked at so far and eliminate answer choices. What's wrong with the first one? It's not proper scientific notation. So if we had all 3, that would be a strike against it. Okay. What about the second one? There. Oh, you monkey farter.
Not again. Oh no.
Come on. Maybe we're there. And I think my little sort of curse didn't get recorded, which is even better. 325,000 with all those zeros. Okay. Possible answer, but that's starting to write out a big long thing. That gets a bit tedious. We might say we should convert that to scientific notation. When we wrote out the 1, 10 versus 100 versus 1,000, okay, right about 10,000, you all started to say to use scientific notation. We're at 300,000. We should probably convert to scientific notation. So what I would do is probably check that last answer over the middle one. Okay? Because that last answer is in scientific notation. Just as one more curveball here, what if that answer was provided?
6 significant digits.
Okay. There's now all of a sudden a decimal point. Subtle difference. I've included the decimal. That's now become 6 significant digits. How do you write 6? 6 significant figures or significant digits. According to our calculation, how many significant digits can we carry through? 3 and only 3. How do we know that? Right there in our 325 milligrams. Okay. There's our 3 sig figs. So the answer, 325,000 with the zeros and the decimal point, is now wrong because that has 6 significant digits, not 3. Okay. Any questions on that?
So the 3.25 times 10 to the 5th.
3.25 times 10 to the 5th is the best answer of those choices. Is that a question? You're just playing with your hands? No? Okay. Okay, my question for you then. How many sig figs? I keep using that eraser. The purple thing. So there's our calculation. That big old purple circle. How many sig figs in that? Why is it infinite? That is a definition. Okay. So when we're trying to determine sig figs, our first one has 3 sig figs. The second one is infinite sig figs. The last one is also infinite, which has the fewest sig figs. 3. Our answer gets put to 3 sig figs. Okay? Questions? So that's too easy. Let's make it more complicated. Everything in the metric system? Absolutely not. Here in America, we use American units, which means we now have to translate science to American and American to science. Thank you, America. What makes this more problematic? Well, we now have a ton more conversion factors. If we wanted to scale up meters, we could just add a prefix and ta-da, it's now bigger. Okay? How do I scale up inches? There's no prefix. What do I scale to? An entirely new freaking unit that has no logic or sense behind it other than on some person's foot, there were 12 of their thumbs in their foot. Nice way to build a measurement system. Okay? So to do these conversions, we have to now have that information. An inch happens to equal 2.54 centimeters. When we move to mass, a pound, 454 grams. Okay? Nice, easy, round, workable numbers, right? A quart, 946 milliliters. I mean, really? Okay. Second, thank goodness, we at least all keep the same time unit. Okay? So that at least holds. So within our time unit, we're okay because we can still use our prefixes in both the American version and the actual science version. Okay? So this now brings up another fun question. When we did our conversions between metric and metric, say meters to centimeters, okay, well 1 meter is, 10 to the minus 2 meters is 1 centimeter. Right? And we have that nice little answer, so you guys should remember that. 10 to the minus 2 meters equals 1 centimeter. Why do you guys need to know that?
Because it's empty.
And
You told us to memorize.
I told you to memorize it. That's why you need to know that. Okay? How many Sig Figs? It is exactly 1 centimeter, is exactly 10 to the minus 2 meters. That is a definition within the unit. It's powers of 10, which means the Sig Figs are infinite. Some of you are shaking your heads, so maybe you see where this is going. Guess what happens when we shift from the science unit to the English unit?
It's not exact anymore.
They're not exact anymore. Okay? Which means if you have 4 Sig Figs that you're starting with and you want 4 Sig Figs in your answer, you have to pick a conversion factor or find the conversion factor that has all of those Sig Figs. Why does that become problematic? The Sig Figs that your textbook gives you, how many Sig Figs in each of those conversions? 3. So you'd have to look up a new conversion factor to pick up that 4th significant digit. Okay, isn't that nice? Okay. Take it a step further. There's a footnote. What does the footnote say?
It's exact.
Some of those English to metric conversions are defined. The one in particular they reference, 1 inch is exactly 2.54 centimeters. Okay. Beautifully obnoxious convoluted system. This is why we should all move to one system that makes sense. The science system. Okay? That will never, ever happen. Okay? But that's what we should be moving to. Absolutely. It will never happen. Too many egos involved. Okay? So, when you deal with English to metric, or metric to English, you have to watch out for your Sig Figs a lot more carefully. Because when you go through and do those conversions, you can run into a Sig Fig issue because your conversion could have fewer Sig Figs than what you started with. Which means that now controls your reaction, or the end result of your Sig Figs. Right? So, next part, we got a nice little problem here. Using the same method that we've been working with, solve this question. First thing I'll ask, how many ways can you solve this question? There's a lot of different ways to solve this question. Okay? And this is one of the issues that pops up when you're dealing with English to metric units and these larger measurements, is that there's multiple ways to go through and solve. Okay? Let's do a quick test. For those of you who got a number 10,972, I think, 0.8.
Yes.
Is what your calculator spit out. Did anybody get a different number? Yes, okay, I need to see your work because I need to set that up. So this is what we got. Okay. Yeah, no, that's exactly what I was looking for. So, in the way that Farzan and Dallin, you guys both did it the same way, did their conversion. So our very first step, we say equals centimeters. We start with 120 yards, which I'll do as our abbreviation. They looked at this and said, I'm going to try and convert across. So they got yards down here and said, well, I can't directly convert centimeters. Fair game. Okay. What did they decide to convert to? Meters. Where did they get that conversion from? It's given to you. So 1 goes in front of the yards, the 0.914 goes in front of meters. Okay. We're now in the meter unit. Okay. Is meters, whoops, let's erase that for a moment. Is meters the final answer? No. Centimeters are. So we put meters down below and we put centimeters on top. Do we know the conversion for that? Yeah. That's our centi conversion, right? And that, we would go through and say that we have 10 to the minus 2 meters, 1 centimeter. And I'm going to need to look at your work here real quickly, because I need to see what your actual number was. So in 2 steps, they went through and got the final answer, or a final answer. Those of you that did not solve this way, how many steps did you do?
3.
Ooh, you did 3, 4 steps. You did more work than these guys did. Okay? And the answer that they got was, where to go? 10,968. Did you guys not write the decimal down? That's fine. They got 10,968. Whereas everybody else went through and did this calculation, and because it's kind of embedded on the top of the screen there, everybody else went through and got the answer 10,000, what was it, 972. Interesting. You both came up with different answers. The next question, both these answers are wrong. Why are they wrong? Sig Figs. How many Sig Figs are we allowed to carry through? And for those of you thinking units, where's our Sig Fig limit?
120 yards.
Comes down to our 120 yards. And when you look at 120 yards, how many Sig Figs are there?
2.
Only 2. The last 0 doesn't count. My bad. It was supposed to count. But at this point, it can't count. Why can't it count? No decimal place. So officially, I'd have to carry 2 Sig Figs. I think I might know where you're going in a second. We'll see what happens. Which means the answer in red becomes 11,000. The answer in blue becomes 11,000. Interesting. Regardless of how you went through and solved this, you get the same answer. Why do we see a difference? Because you're using different English to metric conversions, which then throws the whole monkey wrench into it and it messes everything up. This is one of the issues that I have with Sig Figs and rounding and all of this nonsense. Because depending on what conversion factors you use, you get a different answer. In a multiple choice test, if I had provided enough Sig Figs where the answer came out as 10,968 and you got 10,972, what do you think happened? You think you did it wrong. Okay? This is the issue that I have dealing with Sig Figs. So what I'm saying is that those two, how far off are they? Really, really close. In the case of an exam, you should run it a second time and see if you get the same answer you did. If you do get that exact same answer again, pick the closest and move on. Okay? First you, then you.
Couldn't the length of an American football field be
So I didn't think you were going to ask that. Jacob actually asked that in the back too, on what it is. Is it specifically defined as 120 yards? The question isn't that clear in the statement. If you know something about football, yeah, maybe you'd say it is exactly defined as 120 yards. If you know nothing about that sport, all you have is what's on the board. Okay? So unless this question clearly states defined, you should assume that you should be counting the Sig Figs within it. Oh, Jacob didn't help you out? Oh, because I didn't answer the question. I left you floating.
But could we, like, if this is on a test, could you still argue that it's defined? Because it just says right there.
So everything is just going to say, oh, a measurement or the volume of water was determined to be 120 milliliters.
That's what I thought.
Is that defined? It's hard to say. Okay. Because you have the context of what an American football field is, you're now bringing in that outside context to say it's defined. Okay. The question has to be more explicit than that. How many people, well, this may be a bad question to ask in the US, but how many people have no idea what football is? You can be honest, that's okay. Crap.
I don't know what it is. I know what it is, but I don't have any.
There we go. You've got one person in the classroom that has no concept of what the distance is on an American football field.
You just told
Okay.
me.
Well, now he knows, yeah. Okay. He doesn't know that it is defined as 120 yards. Okay. You brought that context in. He doesn't have that context. Which means if it is being asked as defined as 120 yards, I'm now putting him at a disadvantage. Right? I can't do that. So don't bring in outside context. If the question looks like it's saying it's explicitly defined, then you can say it. Okay? If it's not explicitly saying defined, it's not defined. It's a measured value. Okay? So 1, 2.
Really bothering me. So since the 120 has two significant figures,
Mhm.
and it does say that the inch being 2.54 centimeters is a define, like
Mhm.
it is exact, that's why I didn't go with the meters one. I went with the longer conversion because wouldn't that bring in three significant figures right there?
120 yards. So you're saying 120 yards is defined?
No, it's just, it's two
As soon
significant figures.
if
But
it's
the-
two significant figures, you go by the fewest significant figs. Doesn't matter what anything else is. The fewest sig figs is 2, period.
Yes, but didn't you say that some of the English, the 1 yard to metric?
Yep.
That is not necessarily exact, so that would change.
Some of them are not.
figures?
Some of them
Is-
are.
Is the 1
The
yard,
inch to centimeters is defined.
but is the yard?
Anywhere up there does it say the yards is defined?
No, it doesn't.
It
So
does
by
not.
bringing that into the problem, wouldn't it give it 3 significant?
That would bring in 3 sig figs. Which has fewer sig figs? 120 with 2 sig figs, or 0.914 with 3 sig figs?
Going with the
120.
The
the hu-
120 has.
The 120 always has the fewer sig figs, so it doesn't
I
matter
see
in
what
that
you
case. What we'll do is add another wrinkle on that to see
Alright,
what
just not
happens if we change the number a little bit. Yes?
So what happens if you're doing measurements with AUs? So would they be considered?
They're not
They're
defined.
not defined?
They're not defined. Yeah.
Because they're rounded to the 93, not the 93.
There's
95,
significant
6.
rounding with those. Change the question. It's now, oh man, I erased the unit. 120.0 yards.
Oh, there you
We only have one question or one set of work to look at right now. So that's where I want your focus to be. This is how you now solved that question with this work. And this should get at your point, Alina. What does your answer need to be? You'll notice that when we go through and solve, we'll still have the 10,968 centimeters. Okay, because we just carried a bunch of extra zeros. What do you report your answer to be? I don't even deal with scientific notation, but you're right. Actually, oh, you're going to need scientific notation.
Right.
Well, yeah, in order to make it 3 significant.
How many significant digits do you need to carry in your final answer? Your first one has how many sig figs? 4. Your next one has how many sig figs? 3 sig figs. The next one has? Don't give me none. Infinite sig figs, which means the answer needs to be reported to the fewest. Your unit conversion now messes with this. You lose significant digits because the conversion you have has less significant digits than the measured value. Your answer must be reported to 3 sig figs. So if we go through and underline 1, 2, 3, our first insignificant digit is the 6. What's its relationship to 5? Bigger, which means what do I have to do? I have to add 1. So I could go through and say 1, 0. Whoops. I can't add. Sorry. When you add that 1, it becomes 10, which means you end up adding 1 all the way across, and we get 1, 1, 0, 0, 0 centimeters. What's the problem with this answer? This only has 2 sig figs. You have to have 3. So what do we have to do in this case? You have to be in scientific notation. Wait, 1, 2, 3, 4. Your answer must be reported in scientific notation. Okay? Ouch. Okay, so this, in theory, is what you were talking about, Alina, when you were trying to bring in your units. If your conversion factor has fewer significant digits than what you start with, your conversion factor will dominate the answer. That sucks. Okay? That then messes with your end result. What would you do in a real-world environment? Not use that conversion factor. Look up a conversion factor that has more significant digits. Once you add in those extra significant digits, you now don't lose that information when you go through and do your conversion. Okay? Is that obnoxious? Absolutely. How often does that show up? Really, really rarely. Okay? At the chem130 level, almost uniformly, we run at 3 sig figs. Why do we run at 3 sig figs? What are the conversion factors given to us? In 3 sig figs. That tends to be why we hold at 3 sig figs. Okay? There was a hand. No hand. I'm positive I saw a hand. Fine. I'll just accept it. Questions then? Let's fish for another hand. So comment?
Can you, if you wanted to, do 2.540 centimeters and create that to give yourself 4?
So,
If you wanted to make it 4 sig figs.
shoot, I'm going to have to erase all this.
That one's defined, wouldn't it just be infinite anyways?
What if we went through and ran the conversion, which I think most of you did, 3 feet,
Yeah.
1 yard, 12 inches, shoot, 1 foot, thank you, and what, 2.54 centimeters. Whoops, that's 1 inch.
Yeah.
What if you went through and solved the problem this way? Count your sig figs all the way through. First one, 4 sig figs. Second one,
Infinite,
why is it infinite?
defined.
3 feet is defined as a yard.
Right.
That's a definition of that term.
Right.
You're still within the American unit. That one is defined. How do you know which one's defined and which one's not? That's a harder question.
That's the same as 120 yards being defined. We know that in context of it.
No, yeah, which is why I wouldn't ask the question in this phrasing. The next one, 12 inches and 1 foot. If you asked someone from not the U.S., okay, in theory they don't have the context on that. It's defined. The last one, that's the subscript also defined. Your sig figs comes through as 5. So yes, we'll run into issues where it's difficult to decide is that defined or not. Okay? Within a unit system, it is always defined.
So your sig figs come to 5?
Your Sig Figs, sorry, 4. Did I say 5? It's 4. That was your question.
So, if you do it this way with the significant figures, you can get a very different
You
answer.
get a very different answer.
Do you have to do it both ways?
So this becomes the big question. When you go through and solve a problem, you can end up with different rounding issues and different answers coming out of it. In a multiple choice test, what do you hope? We don't ask a question that can get us both situations. I admit that I watch for these things when I go through and pick problems. That does not mean I'm perfect, but I watch for them and try and make sure that that issue doesn't pop up. In future classes, I make no guarantees, because I'm not your teacher then. And I skipped you.
Could we just leave it as like for scientific notation 1.09 instead of rounding out?
You have to round up. Other questions? Oh, one, and then I'll come back.
Okay, because the given value is already defined as 120, so that means that we have to put this as 2 sig figs instead of 3?
Yes.
If this was the question that we were being asked?
Yes.
Okay.
So we'd have to switch
So
that.
it'd be
put in my lesson.
1.1 times 10 to the 4th, right?
I think that was right. Yeah.
Okay.
Kristen?
So like on the test, since I feel like it's kind of like a gray area if we know if it's defined or not, and like is it the defined measurement or we just are gonna
So
have to
I will
just-
try and explicitly tell you when they are defined,
Okay.
when they are true values. Some of them you know. Within the metric system, those are defined. You need to know that those are defined. Those are defined by the powers of 10. Within the English system, it's a whole nother can of worms. English to metric, rarely defined. Within the English system, it's defined. It's only when you cross systems that you run into this issue of it sometimes being defined, sometimes not. So you got to watch out. Okay. Worst case, on the exam, you look at this question, you go, oh crap, you're really asking me this question, and it's a multiple choice question, and all of my answers are here, what should you do? Raise your hand and ask. Hey, what's going on with this? You said you weren't going to do this. Okay. Where would I ask this question? Because this question is absolutely a perfectly valid question. Homework is a possibility, but we already just solved it, so I don't quite accept that. I would ask this question in the show your work part. I don't care what the number is, I care how you got there. Okay? So as long as all of your units match through, I'm cool with it. I don't care what your answer comes out to at the end because you've shown that you know how to set up the problem. That's what gets graded in the show your work. Okay? Okay, we spent way too much time on there, so I'm moving on, regardless of what you want. Okay, so here's another fun kind of context question. Harry has 100 pennies. Douglas has $3 bills. Sally has 30 dimes. Harry wants to exchange his pennies for dollars. Douglas, who has all the dollars, by the way, is infatuated with silver things and will so only exchange his dollar bills for silver objects. What does Harry have to do to get his pennies converted into dollars, and how many dollar bills can he get?
Interesting. Okay.
Where do these stupid word problems come from?
That's a side note. Wait to figure out the answer on this first. So how many dollars can he get?
1.
Oh yeah, sorry. I thought it was 300. Yes, he can only get 1 penny. What does he have to do?
He has to ask Sally
Convert to
for.
dimes.
He has to convert it to dimes. Then once he's in dimes, he can convert it into dollars. Can we set up a conversion for this? Absolutely. We would set it up where, what do we want as an answer? We want dollars as our unit. What do we start with? Pennies, which I'm just going to write as, I can get away with P, can't I? Yes. Okay, how many pennies do we start with?
100.
Ideally, I go through and run this. I get pennies to dollars. Do I know a conversion to do this?
100 pennies to $1.
You might say 100 pennies to $1. Is that conversion valid in the context of the question? No. So what do we have to convert it to? Dimes. What is that conversion? 10 pennies, 1 dime. I now have dimes. I need to get rid of dimes and hopefully get those into dollars. Okay? What's our conversion? 10 dimes, $1, right? Yeah. Yeah. We can run through our calculation and we end up with $1. Everybody goes, oh, okay, I did that all in my head. Good job. Okay? This is, again, part of the context of why we do these problems. We're picking a problem that you can do in your head. What you need to do is put it on paper. Set up that conversion and write it out. What's the side note? You get these weird, stupid problems that show up in mathematics. They're giving you this stupid, bizarre word problem. Why would I ever solve this? What they're trying to do in those situations is the exact same thing we're trying to do now. Except what they don't do is then abstract it. Okay? They leave you with this problem. You solve it in your head. You get the answer. Everybody walks home happy. What happens if we abstract it? Harry has 100 Snorlaxi. Douglas has 3 Skittle farts. Sally has 30 dimes. Exactly. Okay? As soon as we change the unit, what happens to your context? It completely goes away. How do you do the conversion now? If you spent that last problem doing it all in your head, as soon as I remove your background, your context that you already understand, you've now taken a problem that is the exact same question. And it now becomes virtually impossible to solve because you don't have the work set up to go through and solve. Okay? This is why we're talking about conversion factors and approaching them in this seemingly stupid way. Okay? You need dimensional analysis. You need a standardized notation that allows you to solve questions. Without that standardized notation, you are in your head, and your head is a dangerous, that's a nice way to phrase it, scary, stupid place to be. Okay? If the world got out of their head, we'd do a whole lot better across the planet. As soon as you keep stuff in your head, you start turning it over, flipping it, interpreting a different way, and all of a sudden it turns into a mess. Put it on paper, get it out, work with it. Okay? Unless you're a savant, in which case you're probably already isolated because nobody else can do what you just did, which still defeats the purpose. Okay? So, do we want to go through and solve it now, or move on?
Move on.
Compound units. Okay? Compound units are just another conversion factor. What are the units for the speed of your car? Miles per hour. Okay? That's our standard unit for that. How would we write our miles per hour? You see, MPH. Well, that's useful. Thank you, America. What does that actually mean? Miles over hour. We have a conversion factor. What if you were going 75 MPH? What does that mean? You went 75 miles in 1 hour. You have the ability to convert between miles and hour. Okay. If we switch this up, switch it to standard units, kilometers per hour. Motorcycles traveling at 105 kilometers per hour. What is the speed in meters per second? Just say 5? Oh. So what is our unit? What are we trying to get to? Meters per second. That's the unit we want to end with. Okay. What are we starting with? Kilometers per hour. What's the number associated in there? 105 kilometers in 1 hour. Because we now have a compound unit, you have 2 conversions you are trying to do. You can split this into doing 2 separate problems, or you can run it as one big problem. Which unit do you want to fix first? Kilometers. Good. I want to fix that first too. What do we have to do? Does kilometers show up in the answer? No. What do you have to do? Cancel it, which means kilometers unit needs to show up on the bottom. What unit do I want to show up on top? Have show up on top. Do I know the conversion between kilometers and meters? Yes. What is that? I don't accept that. 10 to the 3 is not valid.
Negative.
10 to the 3 is a number. Numbers have 0 context.
Oh, 1 mile for 1.61 kilometers.
No, it's not miles. We're still meters and kilometers. And it's not, 10 to the 3 is fine as a number. I have no problems with 10 to 3 as a number.
1 times 10 to the 3.
I have a problem with 10 to 3 without the unit. It's 10 to the 3rd meters, which means 10 to the 3 needs to show up in front of meters. 1 kilometer. What happened to the unit? What am I now at? Meters per hour. Is that the answer I want? Did I get closer? Yeah. So what do I do now? I need to convert hours into seconds. So hours needs to disappear from my equation. Say that again.
Put it in the bottom.
Okay.
Cancel it out.
Put it in the bottom. Does it cancel?
No.
So where does the hours need to show up? On the top. Your conversion factor can be put any which direction possible. So far we've only looked at putting a canceling unit in the denominator. A canceling unit can show up in the numerator. How do you decide which one you want? It's whatever you're trying to cancel. Does that make sense? And thank you. I appreciate that. Okay. Ideally we would go to seconds. How many people know the conversion between hours and seconds? Shh. Those of you that know the answer, keep your mouth shut. Those of you that don't know the answer, do you know the answer? Okay. Interesting. If you don't know that answer, that's fine. Can you convert hours to something else? Why did I erase and put minutes on the bottom? I'm still trying to get rid of the hours. The hours unit has to stay there. So since I now know my conversion between hours and minutes, what is that one? 1 hour is 60 minutes. Thank you for the units. Is minutes my final answer? So what do I need to do? It needs to cancel. So minutes needs to show up on top. What needs to show up on the bottom? Do I know that conversion? Why not? You're not just dropping numbers in. What is the conversion? 1 minute is 60 seconds. All right. Now you can deal with your calculator, do all that fun jazz, and you end up with your final answer. All right. Exact same process. All right. And you should be hearing this again and again and again. Every time we get to a conversion factor, guess what the process is? The exact same. It does not change. This is why this method is so powerful. What if you're an engineer? How do you convert units? Same way. What if you're a biologist? How do you convert units? Same way. What if you're a mathematician that actually does, mathematician that does real science? Same way. It's the exact same way all the way through. I have a huge respect for mathematicians. They're just fun to make fun of. Okay? Next one. What's the next question? How far did the bike get in 120 seconds? How do we set it up? Okay, you'll notice how far. So we're being asked to find what? The distance. How do we know we want kilometers?
Because it says in parentheses.
It says it in parentheses, ultimately because the first time I asked the question, I forgot to put the units in. Okay. So we've got this question started to work out for you. I want kilometers as an answer. What did I start with? Seconds. And in particular, I started with 120 seconds. What needs to show up in that next part? Seconds. And what do I want? Ideally to show up in the numerator. Kilometers. Do I have a conversion between kilometers and seconds? If we'd remembered and actually solved that previous question, we could have, but we don't now. So what can I convert those seconds to? Why minutes? What you're starting to do is work towards what conversion factor you already have that involves the unit of time. What conversion factor do we have that has time in it? We have kilometers per hour. can I eventually get seconds into hours? Yes. By first converting seconds into minutes. And then we can convert our minutes into hours. I'm now in the unit of hours. I want those hours to be converted into kilometers. Do I have a conversion factor that allows me to do that? That conversion factor is given in the very beginning of the question. It's 105 kilometers per hour. Where do I put the numbers?
105 from the kilometers.
105 in front of kilometers and 1 in front of the hour. And we end up with our distance traveled. Whoa, that jumped really fast. Okay. How long in hours to go 90 miles? Okay. Again, we're now stacking further and further conversions on top of this. Okay. So you would go through and do that same work all the way through. Same idea. Questions about that? Should we go through and solve that one? Or at least show the work?
So could you also,
Sorry, hold up on that question.
could you also say, because we already calculated meters per second,
You could have used meters per second immediately, yes. If you hadn't solved for that, you don't have it. Okay. Now, should we show the work for that last one?
Yeah.
I'm hearing a yeah. Let's go through and do it. What's our answer?
Hours.
What are we starting with?
90
You'll notice that miles, I will write mi. Why not just m? M might be confused for meters. Good point. Okay. Ideally, I would do miles in the denominator because I want it to cancel. What do I put in the numerator? Final answer, I want hours. Do I have a conversion? Is this given to me in the question? No. That's fine. You don't have it. So convert miles to something else. What can I convert miles to? Okay. Why'd you pick kilometers?
because it's given.
Not a bad idea. It's given, so you could potentially be needing to use it. It's not always true, but in this case it happens to be. What does that conversion tell us? What number shows up in front of kilometers? 1.61. What unit am I now in? Kilometers. Is that my final answer?
No.
No. What needs to happen?
Need to get
I need kilometers on the bottom and I need
hours on the top.
hours on top. Do I have a conversion factor that relates hours and kilometers? Yes. What is that conversion factor?
1 hour.
It's 1 hour is 105 kilometers. Where does this issue pop up? And when we see this digit written for us, we see 105 kilometers per hour. The natural tendency is to put the 105 in front or in the numerator. Does it have to go in the numerator? No. Where does the 105 go? In front of kilometers, which happens to be in the denominator. So there's none of this multiplication division stuff that you sometimes see pop up in physics. Okay? It's track the units solved. Okay. Questions? Okay. Percents. Personally, I kind of hate percents, just because I'm not sure it's all that useful. What you're really looking at is this equation. Use this equation for everything that you're trying to solve. Okay? The percent of something equals that something out of its total sample times 100. Okay? That's all this is saying. So this is how we calculate grades, right? Let's erase that percent, because it needs to be an actual 100. That's all you end up going through and doing. I see you. Give me a sec. Depending on the question, you may see information that says percent by mass or percent by volume. What does that mean? the unit being used is either grams over the grams of the sample or milliliters over the milliliters of the sample, total sample. Okay? Yes?
Is percent considered a unit?
Which brings up an interesting question. If the unit of our quantity is grams and the unit of our sample is grams, what are our units? Nothing. The units cancel. So we end up sort of implying percent as a unitless feature. Okay? There is some implied information in there, but we rarely, if ever, actually show those units. So bronze is an alloy of copper and tin. If a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin, what is the percent copper in bronze? How do you solve? What are you being asked for? What's that question asked for? What is the percent copper in bronze? So percent copper. How do I solve for my percents? Well, it's that equation. 100 times one quantity. What's the one quantity I'm looking at in this case? Copper. What do I know about the copper? Divided by the total sample. What's the total sample? Don't do the math. 79.2 plus 10.8 is now my total sample. What do? Math. Calculator punch in, you've got your answer. Questions? No? You can ask me after class. What happens when we move to the next one? How much tin is in 100 grams of bronze? Okay. That's going to be a little bit more challenging. I want to know the grams of tin in 100 grams of the bronze. That says bronze, or brosny, whatever you want to say. This has to equal what? The percent tin. Okay. Do you know the mass of tin in 100 grams? No. You're solving for it. Do you know the percent tin? Why, yes. The other problem, if when we go through and solve that, will tell us that we have 88% copper, which means what's our percent tin?
12.
Why 12?
That's the remaining amount of the 100.
It's the remaining amount of our total 100%. We can now go through and solve for our grams. Okay? So you can go both backwards and forwards with this system. Questions? Volumes. These are a fun one. Mathematically, your volume, length times width times height. Nice and straightforward and simple. Of course, nothing we work with when we're dealing with volumes is straightforward and simple because we don't measure our volumes in squares or cubes. We measure our volumes in weird flasks. Typically, they aren't that weird. It's just a cylinder, right? Graduated cylinder. So we can figure out the volume of a cylinder by going back to our geometry classes. Whoop-de-doo. Good for you if you want to do that. I don't want to do that. Okay? So we could measure based off of those distances, the length, the width, the height, the radius, all that fun junk. What do we end up using instead for our volume? What unit? Milliliters or liters. That's our standard volume unit. But that has nothing to do with distance. And if we look at our volume, the volume of a cube, we'd have potentially, let's say, meters. Meters by meters by meters. If we look at our volume unit with a distance unit, what would our unit come out to be? meters cubed. Why did we then invent this new unit of liters? How many of you like exponents? Oh, none of you. Interesting. Scientists didn't like it either. They invented a new unit called liters so that we didn't have to deal with these cubic units. That's it. Simple as that. Okay? So, our base unit is liters. It is defined as the volume contained in a cube that is 10 centimeters by 10 centimeters by 10 centimeters. That is its definition. Okay? So what would be liters in a distance measurement? How do you convert liters into a distance measurement? We said 1 liter was defined as what? 10 centimeters by 10 meters by, what does that equal? 1,000 centimeters cubed. How can we convert centimeters cubed to milliliters? 1 centimeter cubed to equal milliliters. How do I convert centimeters cubed to milliliters? Hold up on that one. You're right. Some people know this one, some people don't. We just gave you an answer on what you can convert centimeters cubed to. What can you convert centimeters cubed to? Liters. What is that? What is that conversion? Look at it. It's not 1,000 liters. It's 1 liter is 1,000 centimeters cubed. Is liters what I want as an answer? No. So I put it on the bottom. What do I want on top? Okay, what's the conversion? 10 to the negative 3 in front of liters, 1 in front of our milliliters. 1,000 could also be written as 10 to the third. What happens when I multiply 10 to the third by 10 to the minus third? Cancels, and I get 1. How do I convert 1 centimeter cubed into milliliters? They're identical. 1 centimeter cubed is 1 milliliter. Give me 50 cc's of OxyContin stat. The only drug I could think of. Right? You hear that all the time. cc's. What are cc's? Cubic centimeters. What are cubic centimeters? Milliliters. They are one and the same. And oops, I ran out of time. So we'll pick up on Tuesday with this calculation. Work through it. Watch out. It is tricky.